Okay. Good afternoon, everyone. It is great to be at BazelCon. Thank you for choosing to spend your time here with me today, and I hope you find this talk worthwhile and insightful. My name is Pejman, and I'm going to talk about how to build a great JavaScript build toolchain with Bazel. I would like to start that with briefly talking about a very well-known but seemingly elusive subject: developer productivity. This is a, I guess, long-time passion of mine. It's tempting, therefore, for me to ask what developer productivity is or how we could measure it. But we would likely end up with different answers and run the risk of getting too philosophical. It wouldn't be too productive. But we're all developers here, so let me instead ask a question that I'm sure we all give the same answer to. What does it feel like to be productive? We're productive when we're on a roll. Everything just works the way it's supposed to. And we accomplish what we set out to do without too much effort or distraction. And this occasional feeling of being in the flow of building and creating makes software development fun, right? So I like to think that this state of flow has two elements: performance and simplicity. To be productive, things need to work well, and they need to work fast so we can iterate quickly and feel that we're making progress. If you have to wait a long time to get feedback on the code change that we're making is working well or as expected, then it would be too long and boring to keep us in this state of flow. We'd be easily distracted to check our phone or go grab coffee while our build is in progress or our tests are running. So short feedback cycles are incredibly important for developer productivity, but they're not enough. For us to remain in this state of flow, things need to be intuitive as well and straightforward. We don't want to get distracted by our tools and processes or how we are using those. So in an ideal state of flow, our sole focus is the job at hand. We can find successful examples of developer-friendly tools with these two characteristics in the JavaScript ecosystem. JavaScript developers are spoiled with options when it comes to intuitive tools with short feedback cycles. And thanks to this abundance of options, the tools in the JavaScript ecosystem have evolved to interoperate and play nicely with each other. Naturally, developers expect that from new tools and frameworks, and expect that these tools find their right place in this ecosystem to fit the pattern of other tools and frameworks around them. So unlike this Museum of Arts building in Graz that screams incompatibility. Now, interoperability is important because Bazel is not a set-it-and-forget-it solution. It needs to be fitted and tailored for developers' use cases. And if developers cannot see how Bazel fits within their suite of tools and frameworks, it's only a matter of time for them to ask, wouldn't we be better off not using Bazel? So this treating Bazel as an additional layer of complexity is what drives them to ask this question. So, and that is not productive. In the next half hour, we're going to go beyond how to use Bazel to build our web applications and focus instead on how to make Bazel a better fit for the JavaScript ecosystem, to create a fast and seamless, friendly experience for developers that makes them more productive. Now, a little about me. I'm a staff software engineer at Aurora. I'm part of our technology foundations team, building tooling and infrastructure to improve developer experience and productivity. My team and I help accelerate the development of our web applications by maintaining our core libraries and build system toolchain. I have 8 years of experience in building and maintaining mission-critical software systems. I started my career at VMware Carbon Black, then moved to Canon to build medical imaging software for 3D visualization of CT and MRI datasets. Then left Canon to start a developer tools startup focused on continuous regression testing, which shut down after 2 years. And then I joined Aurora to do what I do today. At Aurora, our mission is to deliver the benefits of self-driving technology safely, quickly, and broadly. Every year, more than 40,000 people in the US and 1.5 million people around the world are killed in traffic accidents. We are building technology that provides an incredible opportunity to save lives, to make our roads safer, and give more people access to mobility. We are always looking for great engineers, so if you like to work for a noble cause and at the forefront of technology, I hope that you consider joining us. We use Bazel at a scale at Aurora to build more than 300,000 targets locally or as part of our CI that runs more than 50,000 jobs per day. While most of our code base is written in C++, we have a diverse and ever-growing suite of almost 40 web applications that are growing fast. So these applications are growing in size and complexity as well. And every month, new applications get spun up and created and added to this list. These applications serve different purposes, from visualization to logistics management. They have varying business needs and business values and are developed and maintained by different teams with different development budgets and practices. Now, while we all make effort to maintain a consistently high software quality across all of our applications, there are always inconsistencies, which makes us end up with a collage of applications with different characteristics. And when it comes to the build process, these differences show up as different configurations and customization points. But we all know from the Hiram's law that anything that can be customized will be customized. And this is my point. Customization fosters complexity. So my team and I work to tame this complexity and to make it easier for the development teams to maintain their applications and develop features faster and easier. We treat other teams as our customers and perform a comprehensive survey every year to identify what their common significant pain points are that we should set out to solve. And the results of a recent survey that we did were loud and clear. Our developers were sharing as their top 2 most frustrating pain points that our builds were too slow and too complex. Naturally, over the past 6 months, my team and I have tried to solve these problems. So here's the story of what we've done and what you could do to make your builds faster and simpler. Now, let's start with the first problem, improving performance. And here's a shocker. You cannot improve what you cannot measure. Improving the performance of any process starts with really understanding it by measuring and profiling every step of that process. Fortunately, Bazel has a very rich set of tools for doing just that. You can use JSON trace profiling to get a detailed analysis of the build process for any given target. You can then feed that profile to Bazel Analyze profile to report the performance of various build phases. And you can then use Chrome tracing to visualize your build profile and better understand what Bazel spent time on. Regardless of what you are using Bazel for, it is to your benefit to learn how to use these tools and use them effectively. So let me show you how. To generate the build performance profile, all you need is to pass -- generate JSON trace profile along with -- profile and the location where you want to write the generated file. At Aurora, we choose to pass a few extra options to get more detailed information and more deterministic results. Now, once you generate the build profile, you can use Bazel Analyze profile to produce a simple summary report. This report also includes the list of most time-consuming actions in the critical path of the Bazel build. But that part is not included in this slide. But the real insight comes from visualizing the build profile using Chrome tracing. In this interactive flame graph, you can immediately identify the performance bottlenecks in your build logic and narrow your focus down to resolving those bottlenecks. What you see on this slide is the actual build profile of one of our most complex web applications at Aurora that used to take nearly 12 minutes to build from clean slate. You can see the long single-threaded action in pink here. That is just a single direct invocation of Webpack that is responsible for a better half of those 12 minutes. This visualized build profile was crucial in helping us improve the build performance of this application by nearly 20% just by upgrading Webpack to the latest version. Now, in any performance improvement project, there are usually a few low-hanging fruits. And we were fortunate to find quite a few low-hanging fruits when we started this task. And the reason was no one had ever started to have a concerted effort to reduce our build times. But in the process of finding those low-hanging fruits, we learned so much about our build process and the deeper underlying issues that resulted in the slow builds. In particular, we were using the JS library from the open source JS rule set developed by the Aspect.dev team to package our shared libraries and application dependencies. These shared packages were then handed off to a simple custom macro that invoked Webpack via a subprocess call to transpile and type check all of our TypeScript source files using TSC and perform other operations like bundling and compression. As all these operations happen outside of Bazel and in the single subprocess call to Webpack, we barely had any opportunity to use the Bazel features and capabilities to optimize that process. So it was all done in one single black box. So we got to work, and in 2 short months, and through a myriad of little experiments, we came up with an improved version of our web application build toolchain that we call the Roadrunner. Roadrunner is intentionally designed as a series of loosely coupled improvements to various components of our existing build toolchain. We kept essential components like Webpack and Jest, but switched to using SWC along with the wonderful open source rule sets from Aspect.dev to unlock 2x faster build times, 3x faster development server times, and 3x faster test execution times. 2x faster build times, 3x faster development server times, and 3x faster test execution times. I see you're all getting excited. Here you can see a visual representation of the performance improvements of Roadrunner for various developer workflows and its effects on various benchmarking metrics that we collect continuously. The green bars in every chart show the relative performance of our applications after upgrading to Roadrunner. So now that hopefully I've shown you that Roadrunner is living up to its name, let's see how it works, and let's better understand what makes it so fast. The Roadrunner toolchain yields significantly faster build times by uploading the transpiling and type checking of packages to Bazel. Instead of packaging the TypeScript source files using JS library and invoking Webpack to process them using TS loader, we leverage the Bazel TS project of the rules TS repository to essentially transpile all TypeScript source files in Bazel using SWC for transpiling and TSC for type checking. We also changed the transformer used by Webpack from TS loader to SWC loader, which results in faster processing and execution of JavaScript files. Similarly, we use SWC Jest instead of TS Jest and leverage the rules Jest repository to enable faster test execution. Let's review these changes one by one. Starting with the TS project rule, a high-performance alternative to Bazel TypeScript from rules Node.js. In contrast to JS library that simply groups source files and declared dependencies together and doesn't run any action, such as transpiling and type checking, TS project performs multiple actions. It validates the content of our TS config file and checks that the listed dependencies are actual TS info providers. It transpiles TypeScript source files and generates JS files. And it performs type checking of all the source files, generating type declaration files and kicking off the type checking of dependent projects when required. Using TS project improves the build performance because it breaks up the work that we used to do in one long-lived invocation of Webpack into a set of the smaller work that we can effectively orchestrate with Bazel. It fits the Bazel paradigm. But we can go one step further and configure TS project to use SWC that is written in Rust as a faster and more Bazel-friendly transpiler than TSC, which is written in Node. SWC is more Bazel-friendly because it is designed to do well in short-lived invocations to transpile a given module without too much overhead. This is unlike TSC, which takes a long time to warm up. And because SWC wants to be a drop-in replacement for transpiling with TSC, it is designed with interoperability in mind. So we can use other tools for other parts of the toolchain. Now, SWC is an excellent alternative to TSC for transpiling, but as of today, our industry really is short of good alternatives to TSC when it comes to type checking, which is inherently slow, compounded by the fact that TS project performs type checking of dependent projects in series. This technical limitation may be resolved in the near future if and when we get a new isolated declarations option in a future version of TypeScript. Now, fortunately, type checking does not need to be part of our critical path. And with TS Project, it is not. So we don't need to pay any performance penalty when using TS Project in workflows with tight developer loops. In fact, in our experience, developers are used to relying on their IDEs for finding and fixing type errors during the development stage. So type checking with Bazel mostly affects build performance in the CI. On top of using TS Project, we found that setting isolated modules and skip lib check in the TS config file to slightly speed up transpiling and type checking, respectively. The option isolated modules allows separate processing of the source files, which plays nicely with how Bazel invokes SWC. And skip lib check allows the skipping type checking of declaration files in transitive dependencies, which is really a compromise between performance and correctness. Let us now move on to a later stage of the build. Once our source files are transpiled and type checked, we still need Webpack for bundling and other things. But Roadrunner changes how we invoke Webpack. Instead of directly calling Webpack by custom macros, we opted to use the rules Webpack repository as another open source rule set developed and maintained by the Aspect team. While this rule set is less polished than rules TS, it enforces opinionated Bazel-friendly configurations to create more deterministic output and enable hermetic builds, both of which significantly improve the build performance. This is a clear example of how we take an established and mature toolchain component like Webpack and massage it to fit nicely with Bazel. Similarly, like how we changed TS Project Transpiler to work with SWC, we can squeeze more performance gain by switching the TypeScript loader that Webpack uses from the TS loader to SWC loader. The performance gain here is not as dramatic as our change to the TS project because we're going to use this loader on the already transpiled JavaScript files. But this change allows us to reuse the same SWC configuration that we used with TS project. Now, rules Webpack and SWC are also helpful in enabling shorter feedback cycles. Now, in this development workflow, we run the development server through iBazel to trigger a visual update of the web application on each change to the source code. But iBazel watches over the sandbox that only includes the transpiled JavaScript files. How do we make our changes to the TypeScript files trigger iBazel? To make this work, we need a little magic trick. We can declare our TypeScript files as assets to the TS project to be copied to the sandbox. This way, we can have iBazel watch over them too. But in this workflow, instead of rebuilding TS project on every code change, we can have the SWC loader in Webpack retranspile the single changed files, which in turn retriggers iBazel to pick up the transpiled file and initiate the visual application update. Here's how this works. We're moving our SWC loader rule into a function that we can call once to match the transpiled JavaScript files, and once in the development server mode to match our TypeScript file. This small trick enables bypassing TS project in this workflow and yields up to 2x faster feedback cycles for developers than they used to get with TS loader. So it's only fair that we also use SWC when running our test. And it's natural to replace TS jest with SWC jest for running our unit test. And this is where SWC truly shines by delivering up to 5x faster test execution times, while almost being a drop-in replacement for TS jest. Now, I say almost for two reasons. One, because SWC jest does not perform type checking. And it's doing less work by skipping the type checking that TS jest does, which is why it's faster. But that's OK, because developers can run another Bazel target, test target to perform type checking as needed. And two, because SWC just handles mocking and spying of jest functions differently than TS jest. So getting things to work as before is not always trivial. Now that our tests are faster, we can go one step further and adopt rules jest to leverage Bazel features such as sharding and more effective caching. Rules.js also elegantly supports the snapshot testing out of the box, which makes it nice and intuitive to run higher level tests. And intuitive to basically for developers to use as well. This is another clear example of how we massage an existing toolchain component, like Jest this time, to fit the Bazel model so we can unlock the benefits of using Bazel. And speaking of higher level tests, we use Playwright at Aurora to enable our developers to perform end-to-end visual regression testing of our web applications. Now, we have our own complex tooling around Playwright, whose details fall outside the scope of this talk. But I thought I'd share the end user interface of this framework here to show you how Bazel is helping us abstract away all of that complexity so that developers can run their high-level test with a simple Bazel run command. Now, this is a good segue to the second element we need to unlock. Developer productivity, simplicity. If you recall, I shared that our web developers identified the complexity of Bazel as their second most significant pain point. I'd like to share how we have tried to solve this problem with the design and rollout of our Roadrunner toolchain. We wanted Roadrunner to be fast to remove slow builds as a pain point for our developers. But while coming up with a nice and fast proof of concept prototype is always a good start, as we all know, the real work lies in delivering the benefits of that prototype into the hands of our developers at a scale, who are our customers, so to make a meaningful impact on their day-to-day life. We wanted to make our improvements easy to roll out and seamless for developers to adopt. So instead of reinventing the wheel, we chose to focus on improving our existing toolchain components like Jest and Webpack. But this rollout presented the perfect opportunity for us to reduce the complexity of our build toolchain by unifying the configuration options we use for our toolchain components across our 40+ web applications. By replacing application-specific configurations with consistent and reasonable organization-wide conventions, we wanted the Roadrunner to be the toolchain that just works. Now, one may argue that building an extra interface is just an abstraction layer that hides away the complexity of the underlying system, but it doesn't remove or reduce it. But building a minimal interface is introducing an abstraction layer with a commitment to revisit all of your customization points and ruthlessly eliminating them. And if you recall, customization points lead to inconsistencies, which foster complexity. So a minimal interface reduces the complexity and makes it difficult for end users to go wrong. And it facilitates further improvements to the overall system by reducing its maintenance and migration cost. And this macro here is the minimal interface that we introduced to our 40+ web applications one by one as we upgraded them to our improved build toolchain. A single macro that is easy to read and make it really difficult for developers to use it incorrectly. Now, this single macro takes the necessary information to generate the variety of build targets that each web application needs. These targets include a TS project for transpiling and type checking, Webpack targets for bundling and running development server, a test target to run unit tests, and a separate target to run our end-to-end test, along with many other targets that our applications use for packaging and deployment. But simplicity is not limited to designing high abstraction interfaces. It is also about removing friction and distraction in the tools that we use. So an example of this in web development is how we use package JSON to declare application dependencies. This is, of course, very different than how we list dependencies with Bazel. But instead of forcing a change of habits, a good design is one that meets developers where they are. So is there a way to let them continue to rely on package.json and handle the mapping of those dependencies for Bazel behind the scene? Now, I'd like to say yes, and here's how. We can maintain a list of all of our web applications that include a package.json file and use that list as input to a custom rule that parses the package.json file and generates this big dictionary we call an NPM dependencies that maps each project to its NPM dependencies. And we can query this dictionary inside our single abstraction macro to make everything happen in the background and create a seamless experience for our end users. And as the cherry on top, and to complete the design of our toolchain, we can go one step further and package our toolchain components into separate packages. This way, our end users don't need to list common toolchain dependencies like Jest and Webpack in their plugins and every other Node NPM dependencies that they include in their package.json file. They get them as a reward of using our minimal interface macro. This modular design also makes it easy to upgrade our toolchain components and our dependencies or replace them with other tools. So I want to close with where we started and say that we can unlock developer productivity with Bazel by creating a build process that is fast and simple. Doing so for web development requires a deep understanding of the web development ecosystem, as well as the true character of Bazel itself. So we can design a build toolchain that fits nicely with Bazel by leveraging its features and benefits and conforming to its expectations. But this is a two-way street. To deliver a great developer experience, Bazel and any build system, for that matter, need to encapsulate their own complexity and get out of the developer's way by providing a simple and intuitive interface. Now, building this intuitive interface needs extra work and requires empathy and a willingness to compromise to make Bazel a good citizen in the ecosystem of tools that developers use every day. And with that, I'd like to thank you all once again for your time, and I invite you to share your thoughts and ask your questions. Thank you. Yes, here in the front.
That dictionary that you mentioned in one of the latter, yeah, that one. Is that Is that a repo rule? Like, how are you?
It is a repository rule. Correct.
It is.
Yes.
Oh, okay.
Yes,
okay.
correct. It's a repository. It's a custom rule implemented in Python that parses our package.json and creates this Bazel module that we can then load.
Gotcha. Okay. Cool. Thank you.
Yeah, sure. Any other questions? Oh, yes, here. Matt.
How do you find the trade-off between what you said about simplicity with like that my web app?
That's right. Yeah, the macro, the high-level macro here.
Yeah, how do you find the
I can repeat the question.
How do you find like the simplicity between like the trade-off between the simplicity of like my web app and like the discoverability of the targets that
Yes. So the question is, how do you basically find a balance between the simplicity and abstraction that you are introducing versus the need for developers to know what targets are available to them for their application? I guess this is a very valid point. That need exists, and the trade-off that we are making is to say, hey, developers of this application, your workflow is to build your app, test your app, run your dev server, run your Playwright server. Remember these 5 targets in your application. Essentially, if those 5 targets are exactly the same name in across our 40+ applications, then it's very easy for us to maintain them. And we don't have to basically go to teams and say, hey, please rename your target or whatever. Essentially, I think that trade-off is always basically the way to break that trade-off is always to think about the maintenance cost. Sometimes that maintenance cost is on the developer side, so you don't want to cost too much abstraction for them to basically have trouble maintaining their app. But in this particular case, and with Bazel in general, I think a lot of the complexity can be abstracted away from the developer's workflows. Another question? Is there any? All right. Well, oh, yeah, one question there.
I think you said that for interactive type checking, you still rely on the IDE working for those purposes. Is that something that worked for you straightforward? Because in my experience, if you heavily rely on Bazel and it's not buildable without Bazel anymore, you probably won't get like don't have like an intact node modules directory that actually works with IDEs that where type checking works. Did you?
Yes, that's a very good point. We try to solve that problem by doing the extra work on our team. So essentially, making sure that developers get that benefit when they're using their IDEs. That their path aliases always include some kind of like alias to the sandbox if need be for them to find their generated files like protobufs and others. So in general, I think yeah, go ahead.
So does that mean that essentially your projects are also still buildable without directly invoking Bazel?
I would say not necessarily, no. We are so heavily invested in Bazel that I don't think we need, at this point, we are not supporting any workflow outside of that.
Okay, thank you.
Yeah, sure. All right, unless there is another question, thank you again, and have a great BazilCon.